If you're building automations, you know the feeling, right? You need to do something simple, convert a PDF, transcribe some audio, scrape a website, and next thing you know, you're pulling out your credit card for yet another monthly subscription. I mean, a lot of us are paying thousands a year for these single task APIs. Well, today we're going to change all that. And look, this isn't just about saving a few bucks. We're talking about a huge shift in how you build things, moving from fragile, expensive scripts to professional, rock-solid systems that are not only massively scalable, but also incredibly cheap.
You know, this quote from Automator Hunter Sneed just hits the nail on the head. It's not one giant bill that gets you. It's the $10, $20, or $50 a month for a dozen different services that just slowly bleeds your budget dry. You're paying for tools you might only use a couple of times a month, locked into these high consumption limits you'll probably never even touch.
Okay, so saving money is awesome. We all want that. But what if I told you that's not even the real problem here? There's something much, much more critical at stake. It's this fundamental technical limitation, like a ticking time bomb, that's baked into the very architecture of most workflows. And it's a problem that you just can't solve by throwing more money at it. So let's start with the most obvious issue, the money. This is what I call the API money pit. It's the problem we all feel in our wallets, but it's really worth taking a closer look at just how inefficient this whole model is. Just think about it for a second. You've got a PDF API for $49, a transcription service for $29, a web scraper for another $49. It adds up so fast. And like Hunter Sneed points out, you're often paying for, say, 10,000 credits when you only need, what, 50? All that unused capacity is just money you're throwing away, month after month after month. All right, we've talked about the money. Now let's get to that technical wall I mentioned, the real killer. This is the thing that separates the fragile amateur automations from the truly professional-grade systems. It's called the timeout trap, and it can bring your most important processes to a dead stop. So picture this. You've got a webhook that kicks off a workflow. Maybe it's processing a huge 100-page PDF or transcribing a 10-minute audio file. What do you think happens when that job takes longer than a minute or two to finish? This slide shows exactly what happens. It's a synchronous failure. This service that called your webhook, let's say it's Stripe or Shopify, it's not going to wait around forever. It sends you the request and it expects a really quick, yep, got it, back. It's kind of like calling for a pizza and being put on hold. If you're on hold for too long, you're just going to hang up, right? That's exactly what happens here. After 30, 60, maybe 120 seconds, the service just gives up, throws a timeout error, and drops the connection. And just like that, poof, it's over. The process is killed right in the middle of its work. The PDF isn't converted, your data is gone, and to the outside world, it just looks like your system completely failed. This is the fundamental flaw of trying to handle long-running tasks with standard webhooks. So, how do the pros get around this catastrophic failure? Well, they don't try to force one tool to do everything. Instead, they build smarter. They use something called a hybrid architecture, which brilliantly separates the brains of the operation from the muscle. This right here is the perfect way to think about it. On one side, you have the control plane. That's n8n. Think of it as the conductor of the orchestra. It manages all the logic, it decides what happens when, and it keeps track of the entire process from start to finish. Then, on the other side, you have the data plane, something like AWS Lambda. This is your specialist. This is your heavy lifter. It does one specific resource-intensive job, like converting that big PDF, and it does it incredibly fast and efficiently. Okay, so how do we get the brain and the muscle, the control plane and the data plane, to talk to each other without falling right into that timeout trap? The secret is this elegant and really powerful technique from professional software engineering called the asynchronous callback pattern. And trust me, it is a total game changer. This right here is the magic. Let's just walk through it. A service hits your n8n webhook, but instead of starting the heavy lifting, n8n immediately responds with a 202 accepted status. This basically tells the service, hey, I got your request, I'll work on it. And then it closes the connection. Boom, no timeout. Then n8n passes the job over to AWS Lambda and tells it, hey, when you're done, call this special URL back. And the n8n workflow just pauses. It waits. The Lambda function can take 10 minutes, 15 minutes. It really doesn't matter. Once it's finished its job, it calls back to that unique URL, and the n8n workflow instantly wakes up and continues right where it left off. It's so elegant, and it completely solves the timeout problem. Now, let's zoom in on the secret ingredient that makes this whole thing possible. It's this special variable from n8's wait node,
$execution.resume URL. This isn't just some static link. A brand new, totally unique URL is generated for every single run of your workflow. It's like a secret handshake that lets your data plane, the Lambda function, securely tell your control plane, hey, that specific job you gave me, it's done. Time to wake up and get back to work.
So, we've solved the critical technical problem, right? We've avoided the timeout trap. That's huge. But what's the actual payoff in the real world? Well, it's absolutely incredible, and it boils down to three key things: cost, scale, and reliability. Let's talk numbers, because the difference here is just staggering. A typical commercial PDF API might run you, what, $49 a month? Easily. Using the exact same logic in an AWS Lambda function, which, by the way, is often based on the same open source code, could cost you 27 cents. Seriously. Thanks to Lambda's pay-for-what-you-use pricing and its really generous free tier, a lot of these workflows effectively run for free or for just pennies a month. You're not paying for unused capacity anymore. And look, this isn't just some clever little trick for small projects. This is literally how the biggest companies in the world operate. Netflix, for example, moved to this exact type of architecture, breaking a giant system into smaller, specialized services so they could handle their massive global scale. You're basically building with the same principles that power the world's largest streaming service. All right, finally, let's talk about a huge hidden benefit to this hybrid model. It's something that saves an unbelievable amount of developer time and prevents massive headaches when things go wrong. It's all about something called observability. So when you have a bunch of different services all talking to each other, debugging can be a total nightmare. If a request fails, how on earth do you trace its path through 5 different systems? The professional solution is something called a correlation ID. It's basically a unique tag that gets attached to a request at the very beginning and is passed along at every single step of the journey. Now, in a pure code world, developers have to build all of this manually. They have to write code to generate the ID, pass it in every single API call, include it in every log message. It's a lot. As the source from the Burning Monk puts it, this creates a ton of unwanted cognitive and development overhead. It's so easy to forget, and if just one service in the chain drops that ID, the whole trace is broken. But this is where using a visual tool like n8n as your control plane is an absolute game changer. You don't have to do any of that manual work. The visual nature of the workflow is the correlation. Every single execution already has its own unique ID, and the logs show you the complete end-to-end journey of your data through every single step, including the call out to Lambda and its return. You get professional-grade observability and debugging for free with zero extra code. So, what's the big takeaway here? You see, moving to a hybrid architecture isn't just about saving money on APIs. It's a fundamental shift in your mindset. It's the difference between building a simple, brittle script that breaks under pressure and engineering a robust, scalable, professional system that can grow and adapt to any challenge you can throw at it. So the real question you should be asking yourself is, which one are you building?